All right, welcome to our last module on attention and impulsivity. So we'll try and make this one go in one video. This is a bit of a shorter module, partially because there's just less research on some of these topics. But what I want for you to get out of this is to define impulsivity and attention in behavioral terms and identify how they impact behavior. Describe the importance of timing and training on reward value. So what is the impact of the delay of rewards on reward value for dogs? And then describe how attention to relevant discriminative stimuli can be manipulated and controlled. So with that, let's start off with target or attention to target stimuli. So an important lesson we know from early 1950s research is that when we have things like complex stimuli, particularly compound stimuli, so stimuli that have multiple components to it. So for example, in this picture, we have compound stimuli, which have two components to it. There's a shape component, and then there's a color component to it. So we can say that these are, think of them as like two little buttons to push. We have one component that indicates a shape, so a triangle versus a circle, and one that indicates color, green versus red. And when we have sort of simple choice paradigms with compound stimuli, so say, for example, I tell you that this is the correct one. So if you respond on this one, I give you $5. But if you respond on this one, I give you nothing. So then I repeatedly reinforce you this for $5, this for nothing. After 10 trials, I then switch to this stimulus. And then the question is what is this? Is this a target stimulus or is this a non-target stimulus? Do you generalize to it? Do you not generalize to it? And in fact, when it comes to sort of the few numbers of pigeons that were tested in this experiment and in other contexts, you can have idiosyncrasy in terms of what is paid attention to or where attention for that stimulus comes from. So what I mean by that is that some animals will indicate that this is a target stimulus because it is the same color as the previously trained one. Other animals will indicate that it is a non-target stimulus because it is the same shape as the non-target stimulus. So in these cases, it's actually an ambiguous trial. Should you respond? Should you not respond? And if all of you've been trained with are these two sort of cues or these two stimuli as cues, it can actually be kind of difficult, and there might be idiosyncrasy in terms of what is attended. This can come up with our detection dogs when they have complex sort of odor compound mixtures. We've already talked about some of the configural versus elemental processing, but say that there are multiple components in there, and those components might have relatively similar values of salience. It could be perceived as elementally, and even in those cases, it's quite possible that different dogs might attend to different volatiles or different components of that headspace. There's actually not a lot of research on that, but even if you think about the entire detection context, right? You can have different ports where there might be different odors. You can have different components of the room. You might have different locations where odors might be hidden. All of these things are built into that sort of compound complexity of what a detection task is in terms of all of the different discriminative stimuli or potential extinction stimuli that the dogs would have to work through. So it's possible that dogs might, you might be thinking are detecting some particular explosives or narcotic, but they could also potentially be detecting where you put your hand right before you placed where said training aid is, right? So just because we think that there's the explosive there, that's got to be the salient component. If your hand touch co-occurs always for where that target odor is, so if this is the smell of your hand, right? And this is the explosive material, right? You have a compound stimulus of two things together, and they both co-occur. It's quite possible that some dogs might very well be detecting the explosive, but some dogs might be attending towards the human smell that is co-occurring at where that target is being placed, or some other thing, maybe the smell of the gloves that you wear, or maybe the packaging in which you wrap the training aid inside of. All of these things that co-occur with your target stimulus can become a part of that stimulus picture, and dogs may attend to it or may not attend to it. But don't despair, you do have some control over it. In fact, you have a lot of control over it, and ways that you can sort of help and facilitate some of this attention is through clever and useful usage of both additional targets or sort of multiple exemplars, basically multiple examples of what the target looks like, and through clever use of different types of distractors. So before we had a complex question of, do you respond to this stimulus or not? But if I were to have trained you with two stimuli like this, you might very well learn that I should attend towards color as the relevant dimension. In addition, if I had trained you to these two stimuli instead, I might teach you that shape is the relevant dimension and that color is a non-relevant dimension. So here, by training these two to indicate shape as a relevant dimension, I can then have triangles of multiple different exemplars with, say, a triangle on a purple background, triangle on a blue background, triangle on a yellow background, and give all of these multiple exemplars such that it becomes very clear that a triangle, regardless of whatever background I am giving you, is your target. And I can use a variety of other colors as non-targets with different shapes like circles and stars and things like that, to all indicate that the only thing that is relevant for you as a target is the triangle, and that different colors and different shapes are irrelevant other than the fact that it's a triangle. Alternatively here, I could give you a wide variety of other colors as distractors, but also a wide variety of shapes as my target. I could give a star plus red. I could give a square plus red. I could give a cross versus red. And as I build all of these exemplars or multiple exemplars, I can then build attention towards just the color as being the relevant dimension. And that by using multiple distractors at the same time that are all going to be varying off of different colors and different shapes would be indicating that the only relevant dimension that indicates whether something is a target or a non-target then becomes the color. And I could do the exact opposite if I wanted to do shape, etc. But the point is that I can control it through the clever use of multiple exemplars of the target, so multiple examples of what I want my target to be, and also through multiple exemplars of non-targets or distractors that are going to have components that might overlap with my target that are non-relevant features, like the bag that I store my training aids in, or the other things that might co-occur with however I sort of plant or put out my training aids, etc. So attention can be difficult to control unless we build in or what components of a stimulus that will gather attention can be difficult to control unless we have multiple different kinds of positive and negative exemplars. Secondly, this can also become a bit difficult based off of some features of the stimulus itself. So for example, another component that will garner attention is what we call salience, how salient a particular kind of component is. You can think about that in your room, that there's a variety of different components within your room that could be gathering your attention. It's probably going to, by this point, if you're watching all of these lectures together, probably very low at this point. But there are probably things that are even lower, like the sound of ticking from a clock inside of your house, perhaps the sound of the dishwasher going, perhaps the sound of the dryer going. These kind of background stimuli are all there that could be gathering your attention, but are not because you've either learned that they are irrelevant through previous learning, or they're very, very quiet while you're focused, on the screen perhaps, or not focused on the screen. So any sound that I make becomes particularly loud, so I get your attention, or I could be very quiet and you may not pay attention to me and get quickly distracted by other things. So the salience, or sort of the magnitude or intensity of different components, can also be differential in gathering attention. This can be critical when it comes to different targets like explosives or very low volatile narcotics, because you might have some components that come with them, like human scent from being handled or being coughed on or breathed on or things like that, that might actually be more volatile and more salient to the dog because they smell like people, which are going to be tend to biologically be more relevant to dogs than are explosives in the natural environment, that those might gather more sort of salience or more attention because there's a biological sort of relevance to them, as well as they have lots of history of smelling people, and there might be of interest there. Versus explosives that are going to be novel and have relatively low sort of vapor pressures, so that things like salience or how intense different components are also going to help sort of drive how important it is that you are working on making the very specific thing that you are interested in, whether it be the explosive component, the non-explosive component, really stick out, is going to be through that multiple exemplar training with multiple examples of what that target is, not just one, but then also using lots of distractors that will then contain overlap of the non-relevant components with your targets. Now I'm just going to swing straight on into impulsivity. So impulsivity basically is the lack of self-control. So what is that still? How do we define this behaviorally, like one of our objectives? And I'm going to say this is going to be the inhibition or inhibiting a response for an immediate smaller reward for a larger delayed reward. So your choice becomes reward now or bigger reward later. And if you can choose bigger reward later, then that is exhibiting self-control or lower impulsivity, and choosing the immediate smaller reward now and foregoing that larger later reward would be an impulsive choice. We experience this a lot, and sort of marketing knows how to exploit this, right? Is that we have something about an immediacy. So there's something about the value of reinforcers and the immediacy of those values of reinforcers that are really, really important, to the point that we could spend $3 for a very small bag of Cheetos right at that checkout point, right as we're about to scan, rather than take our basket out of line, go and get a similar bag of Cheetos for a quarter of the price that's quadruple the size. We just grab that small bag right off of the front there. And we do it because they know that kids will be sitting in the shopping baskets right there. And they also know that we are going to be sitting there potentially hungry, looking at it right there at the point of sale to immediately open that bag and start eating it. Sometimes those little differences in just a delay of just walking down to go pick that up versus being able to open it right now can have really important behavioral impacts on the way that we make decisions. And in particular here, obviously the impulsive choice is going to be buying the overly priced smaller packages versus then either getting the larger package or later health if you don't eat them at all, whatever you want to make that comparison. But just the immediacy of that reward increases the value to the point that you won't walk a little bit further to then go get the other options. Our types of choices between reinforcers can vary between type and quality. So whether it's a toy versus food, whether it's some type of not very palatable kibble versus a highly palatable kibble or treat, the rate of reinforcement, we talked about schedules of reinforcement, so a rich schedule of reinforcement versus a lean schedule of reinforcement, or we can have a lot of reinforcement or a little reinforcement, so a variation of amount. So whether you get paid $10 an hour or $20 an hour, and also the delay. So when it comes to impulsivity, we're typically talking about manipulations between amount of a reinforcer and the delay to that reinforcer, where delay will manipulate how valuable a certain amount is. Can we describe this further? So reinforcement value decreases as the delay between making a choice and obtaining that reinforcer sort of increases. So the longer I have to wait for a reinforcer, the more that value of that reinforcer declines, which means that a treat or playing with the toy right now versus taking 5 to 10 seconds to find where the toy is in my pocket and then deliver it, there is a big difference in the value of that delivery. So the value of that toy, and a lot of the reasons why people are very important about getting the toy right away, or a lot of times people will co-occur about getting the toy at the source. I think part of where people see some of that difference is that by reducing the delay from making that response to getting that reinforcer as being particularly important, so the dog can grab it right then and there, So sometimes reducing delay between behavior to that reinforcer increases the value of that reinforcer for the dog. And there are analog ways that we can look at this in the laboratory. So for example, how do we do this in a pigeon example? And we'll talk about how we do this in a dog example. And it's actually basically the same as in a dog example. But you can have a simple situation where there are two keys. You press one key, and in 3 seconds, you get access to 1 second of food. So it's as much as you can eat for 1 second. Or you press a different key, and you got to wait 10 seconds. But after those 10 seconds, you get 3 seconds of as much as you can eat food. And then there's a delay added to both of these so that there's an equivalent sort of length of time that it takes until the next trial. So you can't just do like 3-3-second trials to get 3 seconds of food in 10 seconds. You essentially are foregoing 2 seconds of food every trial, and then you just have to wait on the back end. So it's basically the pigeon saying, give me the quickest food right now, I'll take a lesser value, versus I'll wait double or triple the time, but get a much higher, more substantial type of reinforcer. So we would call this choice the smaller sooner versus the larger later reinforcer. And we can do similar types of analogs of that in people. So I can ask you, which do you prefer? Do you prefer $80 in 1 month from now? Or would you wait for a year and then I would give you $100? And in full disclosure, I'm not giving you any money at any point, but if I were, what would you have a preference between? And the answer is that we can actually experimentally assess essentially how you discount different types of reinforcers, or in this case, money. So how valuable is money to you, and how does the value of that money decline with time? And in fact, we can model this using the hyperbolic model of delayed discounting. And don't worry, I decided to go ahead and I put the equation here just so that I can talk about this value of k, but we're not actually going to do the math here. If you want to do the math, contact me later. I can do a whole separate thing on the math anyway. But we can, there's a hyperbolic model of delay discounting. There's a couple of variations of the model, but nonetheless, this value of k is what we call sort of a discounting term. And this value of k indicates how steep of a discounter you are versus how not steep of a discounter you are. And typically when we discount different values, there's always a decline in value with time. But some of us have massive declines in value really, really quickly. Those are those of us who are particularly impulsive. Those of us who are not impulsive have a much less steep decline in value with time. And there becomes a point at which in like 4 years from now, we'll value $100 about the same. But the more impulsive ones of us would value $100 a lot more, or say $50 a lot more today than $50 in a month from now, or 2 months from now. So essentially the way that discounting works is that there's a massive drop off in value very, very quickly, and then it starts to flatten out. And sort of the rate of that massive dropout followed by the flattening is described by this sort of k value, and different individuals can have different k values. Different populations of individuals can have different k values, but you can also, and we typically describe individuals with different k values as either being more or less impulsive. So how do we assess this? We can do a titrating procedure where I could ask you, would you like $10 now? So I'll give you $10 immediately right now, or you could have $500 in 12 months from now. And perhaps most of you would say $500 in 12 months from now. At least I would. But then we can make the questions a bit more difficult. Do you want $100 now, or would you wait a year for $500? Would you wait a year for $500, or would you take $200 right now? Would you take $300 right now, or wait $500 in 12 months from now? Perhaps some of you are ready to take the $300. Perhaps some of you are ready to take the $100. Once we get to 400, perhaps most of us are ready to take $400 today, go buy something that we really want, versus waiting a year for $500, or $500 now and $500 in 12 months from now, which we should all be choosing the $500 now, because $500 with inflation is not going to be worth $500 in 12 months from now. So it's definitely more valuable to take the $500 now. So, but we can figure out what is that point at which you reverse from choosing the $500 in 12 months from now to the immediate reinforcer. And that is where we would say you would have that preference reversal. And where that preference reversal occurs can help us better understand what your sort of discounting rate is. Our hyperbolic models, interestingly enough, sort of always indicate that there should be preference reversals for different types of reinforcers at different periods of time. And if we go back to sort of our pigeon example, right, we can have one option, which in 2 seconds, you get 2 seconds of food, or another option, in 6 seconds, you get 6 seconds of food. Pigeons will have an exclusive preference for choosing this immediate reinforcer. But if I added time to both sides, so that say, for example, it's 20 seconds for 2 seconds of food, or 24 seconds for 6 seconds of food, we actually get a very strong preference reversal. And the same could be true is that, say, for example, you chose the $300 now versus $500 in 12 months from now. What would that look like if I was talking about $300 in 10 years from now, or $500 in 11 years from now? Perhaps there would be much smaller of a difference between that, because you got to wait 10 or 11 years no matter what. You might be, well, I'll just take the larger amount at that point. It's not going to make much of a difference. And that's because you, at longer and longer delays, the hyperbolic model predicts this kind of preference reversal. So with all that said, how does this actually apply to our dogs, or anything sort of related to our dogs? Well, impulsive decisions, we tend to sort of conflate or sort of overlap and group with our dogs. Emotional control. So can they inhibit emotional responses to be able to engage in some type of productive response? And this could be really important for our working dogs, is can they, in a situation in which they are very, very excited or perhaps highly aroused, can they inhibit that high levels of arousal to be able to do the task at hand? Or if they have a Kong, can they release the Kong now, which would be basically giving up an immediate reinforcer that they're chewing on right now, for a bigger reinforcer that will involve you playing around with them and going woohoo and having that big play sort of environment? Will they sort of give up that toy right now to then have that bigger reinforcer at a delayed event? Or can they give it up now so that then you can then deliver a higher value reinforcer of throwing it and having another kind of play event? Can they inhibit different kinds of responses that might be impulsive or emotionally triggering, like an aggressive response? Can they inhibit an immediate regressive response to make a perhaps more successful delayed response? Or do they fail, or are they able to make any kinds of delayed choices? In other words, can they bypass perhaps a food that is laying on the ground to walk past that to do their detection task to get a bigger reward, which will be detecting the target odor, delivering the reinforcer, and having a really important playtime? So can they inhibit some of these types of responses to be able to make those delayed responses that are going to have higher value in the future? In particular, it becomes important thinking about it in training is that the whole component makes no sense if the bigger reinforcer is immediate versus being delayed, right? So if you have I can do something smaller and get my whole play reward now versus doing something bigger with more effort and get the same amount or less of a reward later, then it'll always make sense to take the immediate response now. So it's important that we set up these training scenarios where we want the dog to make a less impulsive choice, where there becomes a very clear separation between a smaller reward now and a bigger reward in a short time from now, or some period of time from now. And in dogs, right now, there hasn't been much in terms of can we train this, or can we go through different kinds of training to build these kinds of things in dogs, which would be an exciting area of future research. But there has been a lot of research on how do we measure this in dogs. So can we assess, is my dog very impulsive or less impulsive? So there's actually a questionnaire, the Dog Impulsivity Assessment Scale. If you want it, there's easy access to it online. I can share it with you as well if you'd like. But basically, it's just an 18-point questionnaire. And it gives you a scale to give a general sense of how impulsive your dog is on this scale numerically, and you can compare that to different kind of reference ranges. This will just be answering different questions about your dog. But then there's also behavioral tasks, essentially delayed discounting tasks like the ones that we just observed. So we can set up similar questions like this for our dogs by using different amounts of treats. Do you want 1 treat now? Or do you want, 4 treats in 10 seconds from now? Or will you wait 3 seconds on this lever? So if you push this lever, you gotta wait 3 seconds, but you'll get 5 treats. Or you push on this lever, you get 1 treat right now. Or a different quality of treats. And you can make every time they press this one, it increases in time. So you can see at what point will they show a preference, or will they revert to the smaller sooner, or revert to the larger later. So you can use that same titrating procedure with the dogs, but instead of doing $10 now or $500 in 12 months from now, you're talking about 1 treat now versus 5 treats in 3 seconds from now. Or carrot now versus hot dog in 10 seconds from now, or some comparison of there. And then you can find where your dog shows that reversal, in which they will stop waiting for the larger later reinforcer for a preference for the smaller sooner, or at which point they'll flip over from the smaller sooner to the larger later reward. There's also a simpler version of that, which is the spatial discounting task. And that is basically, you have a similar kind of setup where you have 1 tray with 1 piece of food, another tray with lots of pieces of food, and you initially start them right here at the center point, and pretty much the dogs should show a preference for going to the plate with the larger amount of food. And if once they consume that, you obviously don't let them eat the other one. So once they show a preference between the larger one, you just move the larger one back little bits at a time, right? And at some point, after you've moved it back to a certain distance, it'll get too far away that it becomes more valuable for the dog just to walk to the closer one instead of going all the way to the longer one. There's been a couple of tests on the spatial discounting task, and that seems to be somewhat related to other measures of impulsivity, all kind of as measures of impulsivity. Overall, it does seem that measures of impulsivity seem to be quite stable in dogs, but there are important questions that remain about how well can we train different levels of impulsivity, particularly if it's going to be relevant to different kinds of working tasks, as well as how is it related to kinds of working tasks, particularly when we're selecting dogs at different levels and things like that. But that becomes more of a question on dog selection, which is sort of a whole separate topic that we can get into. But nonetheless, that wraps up our discussion on impulsivity and attention in dogs.